So, what we're doing is we are talking, communicating your maths. So I want you to think this is what we're doing. We're actually not just doing maths now, we're talking about how do you do that communication stuff, how do you let someone know that you're solving the problem, how do you go from a worded problem to more sort of, we're using algebra, so more symbols and notation, okay? So that's what we're doing, and we're solving problems. So quite often if something's said in words and written down in words, it's quite difficult to think how am I going to solve that. But if we put it down in just mathematical terms, it's quite easy. So let's have a look at example 16.
Yeah.
All right. So what have we got? A number is tripled and then decreased by 5 with a result of 19. So do you know how you would turn that into maths notation?
X.
Okay, so the number that we don't know yet is x, okay?
And then Q.
So is tripled, what does that mean?
Times 3.
Times 3, it doesn't mean cubed. Tripled means times 3. So how do we write appropriately times 3?
3x.
3x, good. Right, so the number has been tripled.
And then plus.
And then it says then decreased by 5. So it's minus 5. And with a result of 19. So equals 19. So that's writing it out. So what I would like you to do while you're writing is just think, actually, when I look at this, I think we've already talked about this before, I should be able to look at that and read the words in the same way that I've gone from the words to that. That's what I would like you to be able to do. And then you'll find things an awful lot easier. Right? But do you know how then we'd go about solving that? I hope you can. What would we do? Abby?
19 plus 5.
So I'm going to add the 5 to both sides because that undoes the subtract 5. We've already talked about that. So then I end up with what 3x would have been before I subtracted 5, which is 24.
And then 3 divided by 24 is 8.
3 divided by 24 is not 8.
Oh, divided by 3.
Okay, so we've got 3 x's, so I need to divide that by 3 to make 1x. So therefore, well, if 3 x's are 24, divide the 24 by 3 as well, so I get 1x is 8. Okay, so that's my solution.
Never say 1 in algebra, children.
Never say 1.
Yeah, you never write a 1 in algebra. So you just say
okay.
X.
Yeah. But I can say it.
You can say it, but you can't write it.
You can write it, but we just don't bother.
Don't bother writing a 1.
So 1x is equal to 8. Right. So, a couple of things here. It's the way we solve doing the inverse operations. So we are solving using inverse operations. Okay, one other thing. We are working, so we work writing down the page. Now, I wouldn't normally say things like that, but what I don't want is to see you do it all along in one row. So I think we've talked about this before, where if we do 3x minus 5 equals 19, and then we add 5, which equals 24, and then we divide by 3, which equals 8, we end up with the right answer, but we have not communicated that very well at all. Okay, and we have lied a couple of times. Do you remember me saying that?
No.
Well, because 3x minus 5 is equal to 19, it is not equal to 19 add 5, which is 24. So I've changed my whole problem here. Now I do not know that 19 plus 5 is equal to 24, but it's not equal to 24 divided by 3. Does that make sense?
Yeah.
So we can't write in our line like this. Another thing I would like you to maybe, just to increase your detail, because this is about how are you communicating it. So another thing I would like you to be aware of is if, and I know a couple of you do this, so if I'm solving 3x minus 5 is equal to 19 again, and then I know some of you do this, 19 plus 5 equals 24, 24 divided by 3 equals 8. Yeah, I know, that's,
That makes me uncomfortable.
well, a couple of you do that. I'm pretty sure you do, Ron. Yeah. Because you're just writing the steps.
You literally did it here.
No, but that's just copying from me.
I know, but still, but like, I didn't do it. Yes, you did, because I just made it like.
No, that's not.
That's
But
father's
what
day.
I've not got here, what's missing in here?
What x equals?
Yeah. Well, so I could write at the end x equals 8, and I would get over that. But what's also missing is these intermediate equations. So do you notice up here I've still got 3x's are 24. So I've still got that piece of information in there. Whereas here I've not got, I don't know anything other than when I get down to x equals 8. Now, the reason why I'm asking you to do this is because actually when things get more difficult, you need to be aware what you're doing so you don't get confused. So we ought to write each thing. So I know that 3x minus 5 is 19. I also then know that 3x equals 24, and then I know that 1x equals 8. I've got all three stages written. Whereas here, I know the first problem, but then unless I write x equals 8, if I just write equals 8, I've not actually solved the problem, and I've not shown any intermediate steps. Does that make sense? Okay. Should we have a look then at the next example over the page? So this is important because there's a couple of new things for you. So it says the sum of 3 consecutive even numbers is 132. This is a very important one for you guys. You might want to star this one in your notes and go, important. The sum of 3 consecutive, is that how you spell consecutive? I think so, yeah.
I have no clue.
Yeah, it's in the book. 3 consecutive even numbers is, what did we say? Is 132. Now, do you know what the word consecutive means?
No.
No? No one?
No.
Consecutive means one after the other. So examples of consecutive even numbers would be 2,
4 and 6.
4, then 6. Or 20,
22,
22,
24.
24. They would be consecutive even numbers. So we've got to find when the sum of, so what does sum mean? Adding together. So we want to know if I add those together, do I get 132?
No.
Well, obviously this one not, this one not again. So I could do a bit of trial and error, but it's going to take long, and that's not what mathematicians do. So we've got to form and solve an equation to help us do this. Now, does anyone have any ideas what we would do? Actually, is in the book, I guess. But
Sorry?
Go on.
Yeah, it is in the textbook, but it's kind of like the other one where you have to put, since there are 3 consecutive numbers, you don't know what 3 lots of
Yeah.
is, so you would do 3x.
3x. Well, it's not 3 of the same thing, is it?
No.
But I see what you mean. So we've got to call one of those numbers, the first one, x, yeah? The second number is different, though. It's not x. So what could we call it?
Y.
Right, that's what people would do. We could say x plus y, and then plus z, okay? And we're looking for when that is 132. Now, this is an example where we've used algebra, but it's not actually helping us solve it. So I know I've got 3 different numbers, but I'm not in any better position than I was before, because I've just got 3 different things. I still would have to try and guess what those are. Does that make sense? Because I've got x, y, and z. Now I need to do something different. So what I really want is only one letter. So what I would like to do is say, can I express y and z in terms of x? Okay, so it's these important words. Can I express y and z in terms of? Have you come up across that before? Yeah. So what that means is, instead of y and z, I need x's, and I need to know how to do that.
What's
Okay.
that say?
Why don't you come and sit in front of the board rather than really at a bad angle?
Come on, like
Tough. Go on, go and sit over there, and then you can see quickly. It'll help you learning.
oh, it says terms. Oh,
Tough. Go on, it'll help you. You really will. Right. Any ideas how we could do that then? Well, let me look. So look at these lists I've got. Let's say it was 20. If 20 was x, what do we know about the next one? It will be. Pardon? Is 22. In terms of x, how do we get from 20 to 22? Plus 2. So could I write x plus 2?
yeah. 4.
And then x plus 4. Now, would that work up here as well? So if that was x, is this x plus 2?
Yeah.
It is. And is this x plus 4?
Yeah.
It is. So instead of x, y, and z, I could write x plus 2
What do you have to
plus x plus 4.
Oh, I have to write this right.
Okay? So you were almost right, Haji, with your 3x. But we've got something extra now. So if I collect my like terms, so I've got x plus another x gives me 3 x's. And then I've got plus 2 and plus 4 is plus 6 equals 132. So there's my equation for me to solve. Okay. So how do we go about solving that one then? Should we go for it?
So you take away 6 on either side.
Take away 6. And I'm going to rewrite 3x equals 126.
And then, would you divide that by 3?
Divide by 3, yeah. Which gives me 1x is 42. Now, we've got to check that we answer the question. Because the question says, what are the numbers? So, what is x?
42.
But what is it? What is 42? 42 is the what?
Smallest integer.
Well, you can't have one consecutive number. You need to.
Smallest integer.
But out of the three numbers, it's the I guess smallest integer. But it's the out of the list of three, x was the first one. So this is the first number. So my three consecutive numbers will then be 42,
Oh, that's how you
then
44.
44, then
46.
46.
So every time you do something like this, it's always going to equal even numbers? Or is it
Well, if it says three consecutive even numbers, then
Oh, so that's how you get the smallest.
yeah. So we find the first one using our maths, and then we just go up from there to find the other ones. Yeah.
Would you do the same for that for like odd numbers?
I was going to say, yeah, so if we had to do odd numbers, the odd numbers still go up in twos as well, don't they? But when we solve for the first one, we'll just end up with an odd number. Yeah. What if it was just consecutive numbers, not consecutive even or consecutive odd? So the first one would be x, and the next one would be x plus 1, and then x plus 2. So you have to think it through in that way. Okay? So I tell you what, why don't you, before I go on to the next one, why don't you have a go yourself at exercise 3H and start on question 4 and do 4, 5, 6, 7. So exercise 3H, question 4, 5, 6 and 7, and that'll practice that little skill we've just done. Okay?